In this video, I'm going to explain the derivation for the horizontal range. The equation for horizontal range is given by R is equal to V naught square sine 2 theta over G. Here V naught is the initial speed of the projectile, where theta is the launching angle. Let's see the diagram here. If you launch the projectile at certain angle with some initial velocity, the projectile will have the parabolic trajectory, which is indicated here as with a red color line. By that, this projectile will cover the maximum distance in the x-axis. That distance is nothing but horizontal range. Now, in this video, I am going to explain how we are going to derive this equation. Let's see the diagram again. Suppose if you launch the projectile at certain angle, the projectile will move in this parabolic trajectory. By that, once the projectile reaches the maximum height, its velocity is equal to 0. For calculating this range, I'm going to use the velocity equation which we already explained in the previous video. Now, I am going to substitute v of y which is equal to 0 in this equation. So now what will happen? Once you substitute the value of this v of y which is equal to 0, the equation will become 0 which is equal to v naught sine theta minus gt. Now what I am going to do, first of all, I am going to frame the equation in terms of time calculation. What is the time? Here the time is nothing but how much time the projectile will take to reach the maximum height. Once you know the time, it will be very easy for calculating the total time of flight. Understand? So now I'm going to rearrange this equation in terms of time. Therefore, what will happen when you just move this minus gt to the left hand side, it will become a positive term. Therefore, the above equation will become gt, which is equal to v naught sine theta. Now I'm going to move this g to the right hand side of the denominator. By that, you will get the equation for the time. So therefore, the time which is equal to v naught sine theta over g. Actually, this time is nothing but how much time the projectile will take to reach up to this point. Clear? You have to see the diagram. So this is the time from this point, from the origin to this point, how much time the projectile will take? V naught sine theta over g. Now, if you want to find the total time of flight, it will be very easy. You just simply multiply by 2 because the same time will be happen in the right hand side also. So the total time of flight will be given by the relation caps t, which is equal to 2 times of small t. Now I'm going to substitute this equation here. By that, the total time of flight will be equal to 2 times of v naught sine theta over g. Clear? Now for finding the range, we are going to use the displacement of the projectile in horizontal motion. In the previous video, we studied this equation which is x which is equal to v naught cosine of theta multiplied by time. So here the time for the total time of flight is nothing but caps t. Now I'm going to take this total time equation here. Once you substitute this total time of flight in this equation, you will get the answer for the range. So here this x is nothing but the range. So for calculating the range, you can use this equation also. But the most important thing, you have to use the time of flight equation. Understand? So now what I'm going to do, once you substitute this time of flight here, what will happen? You will get the answer for the range, R, which is equal to, we have V naught cosine theta, but once you substitute this caps t here, you will get 2 multiplied by V naught sine theta over g. Now I'm going to multiply the term because here we have v naught twice the time. So therefore, the range R, which is equal to v naught square. But the most important thing here, we have cosine theta 2 multiplied by sine theta. So we already studied the trigonometry sine 2 theta, which is equal to 2 sine theta cosine theta. Am I right? So now what I'm going to do, in place of this cosine theta 2 multiplied by sine theta, I'm going to substitute sine 2 theta. So by that, the above equation will become V naught square multiplied by sine 2 theta over G. So this is our equation for calculating the horizontal range. Understand? Now the most important thing, when you launch the projectile at certain angle, which angle will give you the maximum range? The angle is nothing but 45. So how I am just telling these things, because once you substitute this angle theta, which is equal to 45 degree, what will happen? 45 multiplied by 2 gives you 90. So sine of 90 is nothing but 1. That is nothing but you will get the maximum range. So once you launch the projectile at 45 degree, you will achieve the maximum horizontal range. Clear? So for calculating the range, you can use two formula. Either you can use this one, or which is equal to V naught square sine 2 theta over G, or you can use R, which is equal to V naught cosine theta multiplied by total time of flight. So both equation will give you the same answer. Understand? That's it. So this is the explanation for deriving the equation for the horizontal range. Thank you.